Unit 1.15C, limits at infinity with exponential functions. All right, limit as x approaches negative infinity of an exponential on top over an exponential at the bottom. Okay, let's go. Let me show you the steps to get to it. Let's go with lim x approaches negative infinity. Okay, let's rewrite it correctly. This is kind of not written correctly. It should be 2 to the power of x plus 3. And the bottom should be negative 5 to the power of x plus 4. Okay, there's no problem with that. Next thing I'm going to do is use the properties of limits, where I want to do the lim as x approaches negative infinity of that function divided by the limit as x approaches negative infinity of this function. Let's do that. So now, the property of limits is that you can go ahead and just go over here and do lim x approaches negative infinity of 2x plus 3. And we're going to do lim x approaches negative infinity of negative 5x plus 4. Okay, so far I think everything is okay. Now, you really need to understand pre-calculus to understand how I'm going to do this. So what I'm going to do is this. I'm going to graph them. So I'm going to graph this first one, this one. Let me graph that. An exponential function, 2 to the power of x, goes like this. It always goes through, y equal to 1. So this is y equal to 2 to the x. Yes or no? You should just know that. And then, isn't it, what kind of shift? Isn't it shifted up 3? Yes or no? Yes. So what I'm going to do is I'm going to shift it up 3. So this one is going to go up 1, up 1, 2, 3. And so this is the graph of this top function, this function. So it does have a horizontal asymptote at this point, 3. So it will never cross this horizontal asymptote, and it will get closer and closer and never cross it. So the limit at negative infinity will be 1, 2, 3. Ah, this makes sense to me. So the limit for the top is 3. Yes or no? Yes. And now, let me graph this one. Limit as x approaches negative infinity of this function. So now I'm going to do this one. Well, isn't this negative 5 to the power of x? Well, doesn't this reflect it about the x-axis? Yes or no? It makes it flip, no? So then, it doesn't, the 5, don't get too confused. It's still an exponential. So it's still going to be, this is going to be the graph. Y equals negative 5 to the power of x. But then it has been shifted what? Which way? This graph has been shifted what? Up 4. Yes or no? Up 4. So then at this point, it's going to go what? 1, 2, 3, 4. And then the graph is going like this. Like this. But the asymptote for this particular one, maybe I should have graphed it in a different graph. But the asymptote of this one is going to be here. So the asymptote is going to be actually 1, 2, 3, 4. So the asymptote is 4. So that's why this is, the limit will be 3 over 4. Yes or no? Got it? Yes? That's the full understanding of what. Because it's going to go to negative infinity. For inputs to negative infinity, it will be approaching 4. The limit is 4. Okay, so that should be good. That's correct. Uh-oh. This is the one that I messed up last time. This is the one I messed up last time. Let's see how I can go over it correctly this time. We're going to do it this way. We got negative powers here. Negative, yeah. So let's continue on with lim x approaches negative infinity. And let me go ahead and do it this way. Didn't we just do this one? How do we rewrite e to the negative x? Doesn't it go at the bottom of the fraction without the negative? Yes, yes. I'm going to do it this way. I'm going to do it this way. That is true. 4 minus 3 over e to the x. That makes sense. And then we're going to go 1 plus what? 1 over what? E to the x. Yes or no? So if this gets really, look. I'm just looking at this e to the x real quick here, because we're going to plug in x is negative infinity, e to the negative some big number. And I'm just looking at the function y is equal to e to the x. And the function y is equal to e to the x. I'm not even looking at 4 minus 3 or not. I'm just looking at e to the x with this lim x approaches negative infinity. So y is equal to e to the x goes like this. Yes or no? Say yes over there, Giovanni. Yes. So this y e to the x goes like this. So as x goes to negative infinity, what's the limit? 0. So lim as x approaches negative infinity, we have a problem because this is going to be 0 and we cannot divide by 0. And this one is going to be a problem because e to the x is going to, as x goes to negative infinity, is going to be 0. The bottom of this cannot be 0 because you're going to go 1 over 0. We got a problem still. So how can we fix this? This is how we're going to fix it. This is how we're going to fix it. And usually I said, why? Oh no, because it makes sense to do this. What I'm going to do is, I'm going to multiply the top and the bottom by e to the x. 1 over and then over e to the x. So e to the x over e to the x is just 1. I'm not doing anything to it. And I'm going to distribute to each one of them. You watch, because that didn't give us an answer. So when I do distribute into each one like this and into each one here, then we're going to get lim as x approaches negative infinity. So that's going to equal to what? 4 e to the x. Yes or no? 4 e to the x. And what's going to happen between the e to the x and the e to the x there? Cancel out. So it's going to be what? Minus 3. Yes? And then if we distribute e to the x times 1, it's going to be e to the x. And then this is going to be cancel out, and it's going to be plus 1. Yes? Yes. Well, we can now do this problem just the way I did this 11. Graph it. So then this is going to be, take the limit of each. So take the limit of the function here, lim x approaches negative infinity of 4 e to the x minus 3. And then take the limit of this function, x approaches negative infinity of e to the x plus 1. But then you have to really understand what these graphs look like. So I'm going to go ahead and graph this one here. So that one is going to look something like this. That it is a exponential. The 4 doesn't do much to it in terms of the graph, what it looks like. So it's going to be something that is going like that, that's being shifted which way? Which way is it shifted because of the minus 3? Is it up 3, down 3, left 3, right 3? Which one? Down 3. So then it's going to be 1, 2, 3. It's going like this. So the limit as x approaches negative infinity of this function is going to be, if this is 1, 2, it is going to be what? The limit is going to be what? Negative 3, yes or no? Because as we go to negative infinity, it's going to be approaching negative 3. So this is going to be negative 3 over, and then for this function, e to the x plus 1 is this function that has been shifted up 1. Well, then where is it going to be approaching? What is it going to be approaching? 1. It's going to be approaching 1. So the answer is going to be what? -3. Please be correct. Is it correct? Because we did it yesterday. Is it correct or not? Wasn't that the answer, was it? Let me see. That is correct. Let's stop that one for this one, or should I have it connected to the other one too? Oh, you know what? Let me have it connected to this one as well. 1.15D, limits at infinity with trig functions. Limits at infinity for trig functions. So the limit as x approaches infinity of sine x. What does the sine function look like? Sideways s, sideways s. So doesn't it start right here and it goes what? It goes up and down and on forever, yes or no? Forever. So that thing is going to go forever up and down, forever up and down. So the limit as x approaches infinity, at infinity, what is it going to do at infinity? It's still going to be doing what? So what's the limit? It will keep oscillating. So it does not have it does not exist. How about for cosine? Huh? It's going to keep going up and down, up and down, up and down. It's going to be, does not exist. The limit as x approaches infinity of sine x over x. If I tell you what sine x over x, we did this one already. What does sine x over x look like? It doesn't, at 1, it is not undefined. I think it just does this, and then it does this, and it just approaches 0. So the answer is 0. So this is going to be 0. And for cosine x over x at infinity is also 0. So you just have to memorize this. So when you do limits at infinity for functions with cosines and like this, you're going to have to do a little bit of algebra before. Because it doesn't look like any of these right now until you make it look like it. So we're going to go what? It is lim x approaches infinity. And you can factor, you can separate. You see, these two are being divided by x. So you can go ahead and just do x over x minus cosine x over x. See, all I did was just kind of divide x by x and then minus cosine x over x. Like that. And so this is going to be x over x is 1. So this is going to be 1 minus, parentheses. And then let's leave that cosine x over x for right now. So the limit as x approaches infinity of 1, that's just 1. That's just going to be 1. And hold on, let me just go step by step then. Lim as x approaches infinity of 1, and then distributing for each, minus lim x approaches infinity of cosine x over x. So this is better. I'm going step by step by step. So lim x approaches infinity of 1 is just 1. Minus, what's this? Well, isn't that the statement we just had here? 0. So what's 1 minus 0? 1 minus 0 is 1. So the answer is 1. And this last one, we're going to go and distribute this inside here. So this is going to be cosine of lim x approaches infinity of 1 over x. So the limit as x approaches the infinity of 1 over x gets really big. So 1 over a million, 1 over a gazillion. This thing is going to become what? 0. So then we got cosine of 0, and you better know your unit circle. Cosine of 0 is what? Unit circle, 0 degrees. This is cosine. This is what? X is 1, y is 0. So this is x, this is y. Cosine is x. The answer is 1. And that is it for today. All right.